Hello, everyone on Zoom, and also here at the Duderstadt Center at the University of Michigan campus. I'm Jonathan Massey. I have the pleasure, I'm going to try to look both at the camera here and at the folks in the room with me. I have the pleasure of serving as dean here at the Taubman College of Architecture and Urban Planning. And one of the great thrills of my time here has been working with faculty and industry experts and students and staff and alumni to develop a new degree program in urban technology. We are now 2 years in to the start of that degree, and so we're about to welcome our next cohort of urban tech students, one of whom came to the room today to join us. Um, but I just thought I'd kick things off by acknowledging that starting a new degree, especially in an emergent field like urban tech, involves a collective leap of faith. You do a lot of research, have a lot of conversations and planning sessions with a broad range of people. You formulate a scaffolding that you think is gonna equip students to thrive in new ways, in new domains, and then you start building. And being at the halfway point of delivering our curriculum is a real great marker of progress for the program. And part of the way we have built up our expertise in urban technology is through um, engaging industry experts through our Urban Technology Advisory Board. And I'd like to welcome, I know at least two of those folks are here with us today, Ben Young and Karen Seidman Becker. And also by engaging industry experts, practitioners through these prototype grants that you'll hear more about today. So this is a very happy convergence of some of the people who are helping us understand what urban technology is and can be. And as I hand things off to degree director Brian Boyer, Karen, I would like to thank you and thank Karen Seidman Becker for her support of this prototyping grant program. It is a real asset to our ability to understand and frame and intervene in this growing field. So thank you and welcome, Brian.
Thank you. Hi, good morning. Like Jonathan said, I'm the degree director for the program that this is kind of orbiting around, right? And I also noticed when we came in that the afternoon session in this room is called the Alternate Reality Initiative, which I think in some ways is like a nice capturing of what Jonathan was describing, where we're trying to create this new program, this new offering, and yet we're seeing different parts of it kind of res in or become real in front of us at different points in time. So the question that's motivating all of this is, what does it mean when data, connectivity, and computation become normal in cities? And we talk about this as changing how we see cities, how we understand what it means to live and how people live in cities, shaping cities, so changing the tools or the processes, the approaches we use to creating the built environment, and also serving, so changing the way that we do things in cities, for instance, how food moves around or how we move around. And the Protogrant has been, this is the second year, it's been an opportunity for us to see some really concrete examples of that, and quite exciting because it makes it real, this thing that we've been kind of imagining. And of course, looking at exciting examples across industry. So the Protogrant is a basically semester-long research project where we invite people from all over the world, anybody who wants to submit, that what we commit to them is that we will offer some funding, we'll offer access to computational and other resources here at the university, and we offer access to mentorship. So connecting outside researchers with our faculty expertise. And the goal is to produce what we would call in industry, an MVP. It's actually like an MVP of an MVP. And so what that means is a minimum viable product is like the most basic little nugget of an idea. And here, what we're trying to do is something that's even fuzzier than that. So we really want people to be doing something that's quite experimental. And because of that, we accept that maybe it works and maybe it doesn't. But even where it doesn't work exactly like we thought it would, there's something to be learned there. So this project is the second year that we've done it. And it's really something that takes a village, like everything that we do in urban tech. And so I'd like to thank, first of all, the jurors, who are the people that looked at all of the submissions and helped us bubble up the three folks who are here today as the winners of the grant. And those folks were Karen Simon Becker, Ben Young, both from the advisory group, Darren Riley, who was a winner and a grantee from last year, and then Jem McGray and Larissa Larson on the faculty here at Taubman, and myself as well. Those folks were really instrumental in helping us understand where some of the most promising opportunities were. And again, we're going to see examples of those. In addition to the jury, Jonathan and Cynthia were also instrumental in making this possible. So thank you for support on that. And the three faculty mentors who were paired with the projects. Some of these names are familiar already. So Larissa, you did double duty, so thank you. Robert Adams, who couldn't be with us today, and then Elisa Nunn, who's here as well. So thank you for being faculty mentors throughout all of this. When we come to the actual projects, I just want to give you a sense of what happened last year so you can start to see the lineage. So last year, there was a project around seeing the city from a perspective of how do we monitor air quality. And Darren Riley, who was the grantee last year, used computer vision to monitor idling trucks in a particular place in Detroit, and to use that as a way of adding to direct air quality monitoring that his company is already engaged in. We also saw an example of a game, an online game for civics. That was a tool meant to help people build an understanding of what it means to live and to create together. And then a third project around using blockchain to control your geo data. So all the traces that you leave through the city digitally, how do you have ownership and control over that? And there was a proposal or a project that was developed that was basically proposing to use the blockchain as an example of how we might build new urban services. So those are just three examples. So you see kind of the lineage. And then here today, we're going to have David Pitt, who's going to present some work on using large language models in an environmental context, which is very exciting. We have Ghislaine, who's going to show us some work on optimizing the EV supply chain, the battery supply chain, basically. And then we have Alexandria, who's going to show us some work in water quality monitoring. So again, focusing on these themes of how we see, shape, and serve the built environment. I just want to say before we get into the presentations, there's a bunch of people in the room, and then there are also people who are watching the webinar online. So for folks online, I'm looking at you. You can put questions in the chat, and we're going to do 3 presentations, and then we'll come to all of the questions as one big cluster. And so we can help read out things that were mentioned on the chat. So please take notes, get interested, and save it for the end of the 3 presentations. And with that, I'm going to hand it over to David, who's our first presenter.
All right. Thanks again, everyone, for being here. I'm David. I'm one of the grantees. Let's see how to work this thing. Oh, there we go. All right. So my project I've named In Brief. As an overview, I'm using large language models to better understand environmental impact statements. So as background, anytime you want to develop anything, in most states except for Michigan, funny enough, you're required to write an environmental impact statement by either the Environmental Protection Act or in California, the CEQA. And these documents have ballooned. When they were first introduced in the 1960s, the average length of an environmental impact statement was 10 pages. And as of 2016, it's over 1,000. There's crucial information in here, but the executive summaries that are required to be tacked onto the beginning are usually too vague, uninformative, pro forma, not really useful. And new AI tools like ChatGPT seem like great ways to understand and summarize this information. But these models are often limited by what's called the context or the memory that it can hold in its language at the same time. So As a setup for this project, I propose to design an AI tool that can extract and summarize information from environmental impact statements, can have a user interface that's easy and simple to understand, and then as a stretch goal to perform both of those two things while staying fast and staying cheap. For the first half of my grant, I delivered this minimum viable product. It takes the following form. The model took in a PDF, split it into text chunks, limited by the maximum context window that I talked about earlier. Then those chunks are all fed into some sort of artificial intelligence model. In this case, it was OpenAI's service. And then they were chunked back together into a summary, and the process was repeated until the document reached an acceptable length. But doing things this way had a few main logistical challenges. Number one was that splitting the document up into chunks and passing every chunk into some sort of AI model took a really long time. Sequentially, I think for a 500-page document, it took an hour and a half. 400 here, I have the figure an hour. The cost was really high. I was just using a textual model for everything. And the price, again, for this much text was $7 to $8. And then the coherence of the document was also not as good as I had initially hoped. The chunks would overlap, or they would repeat themselves, or they would have pretty basic errors. Wouldn't make sense as just one document together. So for the last 2 months, I've been working on solutions to these three problems, and I'm pretty excited with what I have. If there's time later, I can do a live demo. As for speed, I figured out a way to use a messaging service to break up the task into many small tasks that can be run in parallel. That means I have lots of worker processes running on a computer that are doing them all at the same time. For price, I figured out how a way to use cheaper models for less important information and only use one shot of the smartest model available on OpenAI right now for the biggest, most important information. This is where I would have done a live demo if logistics are a little bit different, but there'll be time for that later. This will be the document that I'll demo use on. It's an environmental impact statement for a new wilderness stewardship plan for the Isle Royale National Park up here in Michigan. It's a draft of the document from June. I think it's due to be revised by the end of the year, but no revision's been offered yet. It discusses three main alternative solutions to managing the wilderness in the park. There's one that essentially does not change anything. There's one that builds out or maintains a lot of new structures and tries to increase capacity, decrease congestion by adding more trails. And then there's one that optimizes around the solitude of the park. So later we can see how well the summarizer does at extracting this information. This is what the system looks like right now. So it looks mostly the same as what I demoed earlier, but I've added a query in this green box right here to focus the information that a user would like to get out of the summaries around a certain topic. So you may be able to query the impact on habitats or visitor experience or local land, something like that. Again, the document is split up into chunks, and then I use a bunch of smaller, cheaper, faster similarity models to pick out only the most relevant pages. Then I concatenate these pages together into one longer document, pass it through GPT-4 Turbo. I figure out a way to get sort of the maximum context length out of this. And then out the end comes a very coherent, nice summary. On my 3 bullet points, the speed is much better. Doing everything sequentially and using faster models brought down the net time to 2 or 3 minutes. The price is less than a quarter for a nice executive summary, and the coherence is much higher because I'm only using one shot of a language-to-language model. Briefly about OpenAI, my service depends on OpenAI right now. It's saved me a lot of time and a lot of money and energy instead of having to provision permanent cloud compute and run my own model service, which I looked into. I would have to spend time essentially for a service that I would use maybe a minute a day. So instead, I can just pay by the query to an OpenAI model. But since this all rests on OpenAI's infrastructure and they're constantly developing new things and they've been in a little bit of flux lately, there's a concern about long-term stability. On the good side, the models have gotten a lot more powerful in the last year. When I first proposed this project, the latest model was what was called GPT-3. It could give decent answers to simple questions, but it couldn't really perform well on more complicated logic and natural language understanding. The GPT-4 model is anecdotally much more competent, especially at the task that I have it doing. But as a long-term stretch goal, for reasons I'll talk about, I would really like to move off of OpenAI. I talked to a lawyer friend of ours, and I got some feedback. We got to summarize different versions of the same document to try and extract the differences between three revisions of an environmental impact statement for the Colorado River Basin. And it seems like the tool worked pretty well, but she wanted me to highlight that this tool isn't really useful except for public information, because since all of this information that you're sending is going over a public network and it's being sent to OpenAI, you would violate confidentiality if you would use this tool on anything besides public access information. I want to keep the tool open source too, and any adaptations to this would require a custom service that I would have to build myself, which I think could be a cool stretch goal, but a big scope change. And that's all I have so far. I guess we're doing questions at the end, but yeah. Thanks. Should I pass it off to Alexandria?
Hi, my name is Alexandria. I'm a mechanical engineering grad student at MIT, but my background is actually in human rights activism. And so whenever I'm looking at engineering, at designing or building something, I'm really more interested in it for the impact that it could have on the world than just for the sake of technology itself. So there's a problem with environmental data, and it's that environmental issues disproportionately impact minority communities, but the EPA is less likely to validate the data, and that data is frequently self-reported by the people who would be creating the environmental issues, like the companies. And so there's an over-reliance on these unverified corporate data reports, and in order to validate them, in order for community to say, I don't believe what you're saying, they would need access to incredibly expensive sensors, ranging from like the high hundreds to thousands of dollars just for a single sensor for a single part of like one river. So it wouldn't really be feasible for a lot of these communities to go back and validate what these companies are saying. So our goal is to develop a cost-effective and easy to assemble water quality monitor that uses both the more accurate water quality monitors and much more low-cost water quality monitors on the scale of about $100 for all of them together in one sensor, and to deploy them as a network, which would allow us to get hopefully almost exactly the same data as it currently costs thousands and thousands of dollars to retrieve using low-cost water sensors and machine learning models. And something that we were really passionate about is making sure that communities don't need access to like significant machinery or to a lot of technical knowledge to be able to understand how to assemble and how to understand the results that come out of these water quality monitors. So we focused on key water quality parameter indicators, including pH, turbidity, electrical conductivity, and temperature. So here is the sensor. If you're here in person, you can, yeah, that's going to work. Let's see if we can unblur the background. Okay, there we go. A sensor. Okay, so if you're here in person, then you can come and look at it afterwards. And I'm happy to answer any questions about like, what does it do? How does it work? But sorry for everyone who's online. So essentially the goal of building the sensor is how can we assemble it using everyday tools like a drill or something that could be purchased for like a reasonable amount, like a soldering set, which would be about $50. And our major technical challenges were, how do we address these inaccuracies? So low-cost sensors tend to be inaccurate. And what inaccurate means could be maybe they turn themselves off randomly. Maybe they have significant drift. So like they need to be recalibrated constantly. For example, one of the pH sensors at the top end, it tends to rank like it scales high, at the bottom end, it scales low. So not super helpful if you were just trying to deploy it on its own, but it is error that we can fix versus something like the sensor like turns itself off or it shorts or it's not fully waterproof, which isn't really something that is fixable in the scope of the project. So we actually went through, I think, 64 different sensors to determine which ones were things that we could actually fix and incorporate into the project. So the data monitor has IoT and Bluetooth module and as well as Wi-Fi, so you don't actually have to be in front of the sensor to be able to access the data from it. And waterproof doesn't necessarily mean waterproof enough to put in a river, so we had to do a lot of work with effective waterproof and energy efficiency strategies. It has a solar module on the top, and that's enough to run these sensors theoretically for a week on a full charge of the battery. So if it was cloudy for a week, you could still collect data. And we want to be able to deploy not just one of these, but like networks of the sensors in order to run the models. So they have to be able to communicate with each other, which is why we use IoT. So the problem with low-cost sensors is that they're inaccurate. And so how are we going to fix these inaccuracies? Well, the answer is machine learning. So we're using machine learning to compensate for these inherent inaccuracies. And we're using these algorithms to identify and adjust for the errors in the sensors. There's an overview of how we trained and collected the data, although this honestly is like a day's worth of presentations. So we collected data basically under as many conditions as we could in a lab setting in order to then create more data because we couldn't collect enough data to train the AI model. We're using the Atlas Scientific sensors, which are lab grade sensors, as our like quote unquote ground truth values. And then we're ensuring that the model is applicable in different environmental contexts by trying to incorporate as many different environments as we can. But none of this matters until we prove it works. So ultimately what we need to do is deploy a network of sensors in multiple different locations across multiple different parameters and use the AI to see if we can fix the things that we broke by using sensors that are lower cost. So currently we have developed and tested a functional prototype. The device can be built and deployed without technical experience or access to expensive tools. We can also remove the soldering component. So these solar panels need to be soldered, but there are other options that would not. We analyzed 64 commercial low quality water sensors, and we made preliminary modeling of sensor error in lab settings, which does look promising for the ability to use machine learning to correct these errors. We are also ready for the deployment in real world environmental settings. This one will hopefully be deployed off of a dock at MIT in the next few weeks. So the next thing that we're doing is initial testing in a local river that will allow us to continue refining the AI model and collecting environmental data. Ultimately, we probably will not be able to collect enough data to train the model. So we're probably going to use data augmentation, which will allow us to generate more data that will let us do the project within like a reasonable amount of resource constraints. We also are really committed to working with communities. So we want to partner with the community to do full sensor network deployment and then conduct network simulations to better understand how we can optimize sensor distribution. So maybe we only need like 3 or 4 of the more expensive sensors in a whole river, and then we can use maybe like 50 of the lower cost sensors. And we want to make sure that as we're doing this, we're developing user-friendly documentation and documentation that like assumes absolutely no technical knowledge, as well as establishing like a volunteer support team, because sometimes you just need someone to like sit down and walk you through how to do something for the first time. And that way we can allow people of all different technical levels and access to resources to be able to like build and deploy prism water sensors.
Hi, everyone. I'm Gisle, Gisle Lacoze. I'm based in Rwanda, in East Africa. So I run a company called Wayzone, which is on a mission of redefining urban mining. So we utilize AI technology in extracting materials from existing devices, especially obsolete devices, ensuring that we can repurpose them or either extract secondary raw materials which are sold to manufacturers or recyclers that can be other raw materials for future products. So early this year, we tried to pivot our material traceability technology in EV industry. And we came across to the Protogrant. We decided to apply, and we're so excited to share key results that we had in this project throughout this year. So for a little bit of context, in Rwanda, the most common mode of transportation has been the motorcycles, which move around the city like Kigali, transporting people and goods. So at initial inception of the project, we met with Eric, that you can see here on the screen. So Eric is the father of two and relies on this e-motorcycle to actually provide from his family. But on one end, he spent almost $150 repairing his e-motorcycle on a monthly basis. So this is kind of like 20% of his monthly income almost spent on auto repair. So, and on one hand, he also spent almost 2 to 3 days almost waiting for auto repairers to hand over or to return back his motorcycle, which is like a loss of income because he was supposed to be providing family for about those 2 or 3 days. So at Wayzone, my company tried to reimagine the solution. How can we facilitate Eric with other 5,000 e-motorcyclists in Kigali to reduce cost as well as save time that they incur auto repairing their e-motorcycles? So we came up with a concept of providing real-time data throughout 2 different stages. So while our initial thought was to provide a dashboard, our solution evolved to become something really unique that we didn't thought about. So like as we go through the presentation, we see how it evolved. But ideally, we want drivers or e-motorcycles to track provenance of their batteries. So basically to know the current status of their batteries, as well as even predict some auto repairing needs that they might kind of get in 2 or 3 weeks. And also create post-consumerism value. For instance, if the battery is obsolete, they can actually get the opportunity to sell it to repairers or recyclers or manufacturers, basically return it back to manufacturers and get some incentives. Yeah, and designing a solution, we thought about how could we get such data? And we designed a laser scanner technology, so which is just a simple tool of detecting mineralogical content of batteries or EV critical components. And as you can see, it's just a quick device that we install at EV charging stations so that each e-motorcyclist can actually pass by while they're charging their batteries. They can also get the opportunity of scanning their batteries so that they kind of get the real-time data or on the status of their batteries. the data generated by this laser scanner is composed of different electrochemical data, which are captured by various sensors at different distance. And then such data are transferred to a dashboard. And as we suggested, like Ari, it was just simple dashboard that could allow them to gate or visualize the data that they need. And such data could range from provenance, so like how electrochemical are actually changing their batteries, but on one end also providing real-time recommendations on what they have to do. While our end goal was to provide a dashboard, during the project, a majority of the users were really claiming that they don't need a dashboard. What they just need is information, which allowed them to make informed decisions. So that's how we came up with this concept of providing SMS-enabled information. So rather than spending time navigating throughout the dashboard, what they just need is simple information delivered throughout SMS, as well as a quick recommendation. As you can see, we can provide the status report on their EV batteries, as well as even highlight a quick recommendation to take, either to take their EV batteries to auto repairers so that they can get assistance. We also attach a report, just detailed report that they can provide to auto repairers or another third party so that they can assist them in repairing that. Yeah, we were surprised, but maybe I will highlight that during some of the key lessons that we learned. Yeah, but we tested this with almost 100 motorcyclists that were involved in the project. So this is a charging station in Kigali where we placed the laser scanner. And among those 100 motorcyclists, 23 had some amazing results because they have been able to save an average of $150 as well as the 3 days of repairing by relying on this laser scan technology. And so it's just at the inception phase, but we believe in upcoming months we get like just substantial results to measure the impact of the project. Yeah, like as I was saying, one of the key lessons that we learned is that design, especially UI/UX design, should be led by community. So while designing a project, we involved Eric during the conceptual design, and we want to hear just from his own context what we can do as just final deliverable of the project. And while presenting the dashboard, he was like, no, this is not an ideal output that we would like as a driver because we don't have time to just navigate throughout the dashboards. If you could just see another concept of delivering information easier and convenient for us, I guess it could be just more advantage. And so we involved him in UI/UX design. So he was the one who was actually reading the whole designing, the product design, and it was really productive. And I guess it's just a key lesson that we need to integrate, especially in high advanced projects like these, involving the community and let them own the project, especially at design stage. And beyond that, we also faced some challenges during data correction. We emphasized on quantity rather than quality, which is really a huge problem because we incurred some biases, especially output biases. And rather than focusing on quantity, we should have like focused on quality, especially on the relevance of the data that we wanted. For instance, initially the dashboard will predict some maintenance costs, which are quite higher than local markets. And you could just provide like some biases and say, oh, how am I going to afford this? So we had to go back to the field just to collect more data just on local pricing market so that we iterate the whole dashboard. And then beyond that, we saw some growth, especially in EV uptake, not just in Rwanda, but in the whole African continent, because people are so eager to try new technologies, but they want it to be more transparent as well as have like a trust in all those technologies coming on the continent. And we believe projects like this can actually create more transparent process, especially providing real-time data, which allow them to make informed decisions, save cost and time. And beyond that, with the wave of AI spreading across the globe, we feel like the lack of infrastructure might kind of like drive emerging economies, or maybe emerging economies might miss out from such opportunities because some of our data are really quite insufficient, especially social and economic data, which can support such uptake. And luckily, companies like Oracle, Google have already started to establish research centers. I think there is one coming in Kigali this year. So even though it's just at early stage, but something that we need really take into consideration as we spread these AI projects across the continent. So for the next steps, we project to continue correcting data, especially to avoid such biases that we mentioned. And we also trying to imagine the way that we can create web access, even though a majority of those e-motorcyclists suggested SMS output, but some key players in EV industry also need access, especially the way that they can utilize or get industry reports on EV maintenance as well as EV uptake. And we believe that we will be able to create like a public access dashboard. And we have also reached out to the Ministry of Infrastructure, and we'll be able to create a more holistic plan on the way that we could expand this project throughout the country. And they have promised the support in expanding the project. Yeah, so yeah, that'll be all.
So thank you very much, the three of you, for sharing your projects. Does anybody have questions that are on the top of your mind? Bronco.
Like really cool project. I really enjoyed it. Out of curiosity, it seems like a lot of you are leveraging a lot of these tools that even a few years ago one could argue have a pretty high barrier to adopt, no matter what your timing is in general. So even without that prior background, do you get the sense that you may be moving pretty fast? You know, like how do you feel about the tools that are available to you these days to spin stuff up at the pace that it seems like you are? General kind of takeaways.
Hi, will you repeat the question for those who are online?
Yeah, I can do that, but I think, do the microphones pick it up? Because otherwise the answers won't come back. Okay, sure. Yeah, that works. So that while that's happening, so the question was, all three of the projects use tooling that's relatively recent, right? So cheap, easy access to machine learning models. I'm going to assume there's some containerization, so being able to spin up an instance of something very quickly, and also affordable hardware. And so to what extent do we feel secure about that? Is that fair?
Okay, I think it's all matter of conceptual design. I mean, on our end, we were familiar with AI application in emerging economic context. Why it might just be designed as an infrastructure. On our end, it was like an infrastructure. So we utilize it internally just to generate data. And but the end users were not really interacting directly with the AI technology. So while it might be at early stage, the adoption should just go hand in hand on UI/UX design, on the way that we rethink the users and the way that they can access the technology. But otherwise, I wouldn't say that it's too early. as long as you design the final product in a way that's more interactive, the user based on the local, so basically based on local and social economic context.
So one of the things that we're really concerned about is the fact that with these low-cost sensors, what if one of the companies building one of these goes out of business? What if they come out with like a new model, stop selling the old model, and the new model has like a completely different issues with it? And that's something that, or honestly, even within the same brand, within the same sensor, some of them behave differently. That's like the problem with low-cost sensors. And we're still really trying to figure that out. The more that we get to like larger and larger scale deployments, it's possible that if you swap out one sensor, you can still fix it. If you have to swap out all of them, will the same model work? Probably not. And so there's a lot of potential issues there. I also think that one of the cool things about this approach is how modular it is. Like you can retrain a data set or you can retrain a model based on things that are changing. Also, these sensors, while they do get updated and changed, they are pretty consistent. So for example, we have like, I think 3 or 4 generations of like pH sensors from DF Robot. And those are like very consistent in the way that they behave. But if they change manufacturers, like the label might not even change. And we wouldn't necessarily know until we start getting weird results out. So yeah, there's definitely risks with that. And I think the only way to eliminate it would be if we built our own sensors.
For my part, this project would not have been able to do in 6 months last year. I mean, these models have gotten so much more powerful, so much faster, so much cheaper. Of course, there's risk. Of course, AI is in an interesting place where people study machine learning models as phenomena as opposed to designing models with a concrete idea of their capabilities. That's different from the way that most math and computational modeling has been done historically, but look at the results. It's pretty exciting.
Rob?
Just wanted to ask Ghislaine, what is your X-ray sensor detecting? It was just unclear to me. Yeah, exactly kind of what your
is
sensing.
And if you can just repeat the question also.
Okay.
It was something about different metals, but then the SMS had like a different information. Just clear, yeah.
Yeah, sure. Yeah, I got the question. So yeah, so he's asking what kind of data the laser scanner actually generate. So the laser scanner is applied on EV batteries. So there are several components on e-motorcycle that can be scanned, but we prioritize the batteries. So it generates different electrochemical data. And the idea is just to check provenance or change in such electrochemical data. And then we analyze them and provide detailed information. So we have a way of categorizing battery efficiency levels. So we can indicate if the battery efficiency level is on average or high or low. So and then we provide this SMS output containing such data. We try to simplify as possible because it's actually going to the e-motorcyclists who might not be just aware of such scientific terms and provide them the final decision either if the EV batteries at average or low or high level, as well as even a recommended approach to take, either to take it to auto repairers or doing nothing, or maybe taking like 2-3 weeks to consider auto repairing. Yeah, so basically real-time information on neurological content, analyzing the context that can be explained to non-scientific e-motorcyclists.
The chemical composition of the battery actually allows you to understand its
No, chemical and physical both at the same time.
I'll ask you a bit about, so an environmental impact statement, I've seen them, they are very long. What is the product then? Are you summarizing this? Because in some ways, without comparison, it doesn't mean much.
That's true.
Okay, so let's hear
Sure.
a little more.
So I can do a little live demo actually. Let me show you this. Let's figure out how to get onto Zoom first. All right. Yeah, I think we need to enable screen sharing. Yeah, it's the little down arrow right there. Yeah.
Okay, so I think I just need to unshare.
There's that one. I don't think you need to unshare it. I think it'll automatically take over. Let's see.
Or simultaneous.
Yeah. All right. So are we seeing a desktop or do you need to stop sharing? All right.
There we go.
So here we are. I'm inside this directory here in my terminal. Let's run this. So now this has just spun up a front end on my computer. And this is what the product looks like right now. This is on the left side is the product itself, and here's the front end interface. So we have this document downloaded here, which is a nice long PDF. It's the ISPRO draft proposal. And say a user is interested in the impact of the proposal on visitor experience. And summarize this. Usually takes a little while, but then the document's just uploaded. It'll take us to a placeholder loading screen. And here are the 10 decentralized worker processes. They just summarized every page using one of the cheat models and returned a similarity score between 0 and 1. So to your question about summary quality, this will take a minute or two. That is one of the things that I struggled with the most throughout the process of this grant. There isn't really a great accepted metric for summary quality because you either have to depend on very subjective human annotation, that's, a quorum of individual readers of these long documents who compile their own summaries, or you have to use older existing language models to generate some kind of summary score. So no matter what you're doing, you're bootstrapping your metric of summary quality based on models that aren't really state of the art. That was really hard to measure. So the best approach that I arrived at for this project in this stage was to do anecdotal testing. And look at that, we got a summary. So remember, the document here talked about 3 alternatives, one that provided little or no modification, one that did large restructuring, building new structures, and one that destroyed some of the structures, I think, and added solitude. So here's our summary. It's around 800 words. I even asked it to format an introduction. The kind of prompting you can do with these models these days is really cool. I think if I had this be a markdown window, which is a text formatting style, it even would have formatted these to be bold and italicized and things like that. It's really cool. So let's see. The summary analyzes 3 alternatives: no action, proposed action, preferred alternative, and alternative C. Alternative A maintains the status quo with minimal changes, preserve current visitor experiences. Alternative B improves visitor access. Alternative C is restoring campgrounds to their natural state and removing shelters. It talks through the comparisons in this middle section, and then I asked it to provide a conclusion, which I think is here.
David, you also worked with somebody who has more domain expertise.
That's true,
area,
yeah.
Right? So maybe you could talk a little bit about how you did some ground truthing with that.
Sure.
Party.
Yeah. So wasn't quite ground truthing, but I got some really good information. This is a family member of ours who works in environmental law. Her area of expertise is water rights. So she had me summarize 3 different documents from I forget the name of the process. 3 different documents from 3 different stages of proposing an action by the Department of Water and some sort of Colorado River Basin water sharing agreement. Sorry? Probably, yeah, could be. I have the document somewhere in my computer. We can take a look. But the relevant information was sort of spread out through 3 or 4 sections of the document. Document was 800 or 900 pages. And it just wasn't feasible for even a practitioner like her to go through the document every single time the revision was updated. I think it was 3 times over a few months. So we were able to use this tool using a prompt about the impact on habitats, because her concern was about whether the Bureau had done enough research and had made enough considerations about the impact of this water sharing plan on the local habitat. And we were able to see that between 3 versions of the same document over time, because of some pushback from activists and from lawyers, they added new sections to the document about impact on habitats, and they added more information to all of those sections in a way that wasn't totally explained in the document, wasn't totally predictable, just like buried in all this information. But using the querying and focusing strategy that we have here, it was able to extract that information in a pretty effective way.
Can I make a recommendation? Again, I'm thinking about users,
Mhm.
know. So you give these to it's a form of obfuscation, really, is when people give you these massive things and say, okay, figure it out. So I'm thinking about a low-income community. Could they use this, and could you identify a really high-quality environmental impact assessment and say, how good is the assessment done for our project relative to that project? Because a lot of it is a comparative thing. And I mean, just pulling out things, if you looked at them without comparison, they don't mean much. But if you say, wow, they really dug into the environmental justice of this, they looked at community demographics, impacts, things like that.
Mhm.
Is there a way to do that?
Definitely. I mean, a lot of it would come down to a choice of a quantitative and interpretable metric of the quality of a statement like that. There are many ways to do it, and it would have to be designed from the ground up, a metric like that. But with time and with a focus on the right stuff and with the right experts, I think that'd be pretty feasible.
Elaine, you forgot to mention the barcode scanner.
Oh, yeah.
I'm really excited about it. But my question was actually for Alexandria. So this is, why did she decide that you needed a Bluetooth Wi-Fi solution?
So basically, right now we're putting the sensor like on a dock because we can get to it when things don't work. But in the future, maybe someone wants to like deploy it off of a bridge. That's like one of the common ways to do like continuous sensor deployment. And then you'd have to like pull the sensor all the way up from the bridge to get the data off of it. Also, you'd have to open it to get to the SD card, which means that you could mess with the waterproofing you did. And so it probably is just easier to be able to like stand on the bridge and go like scan and then get your data without having to do that. So yeah, it was just like a practicality thing.
Okay, I wanted to ask, because you have a really impressive like works like prototype, but as you enter the next phase where you're thinking a little bit more about the deployment and the user deploying it particularly, it'll be interesting to reevaluate the technical requirements and maybe think of it in terms of something even more low cost, so like a USB, like just like a USB data collection sort of thing that you do off of like a tractor or something, just because there's also less complications around that. And then you would also have an opportunity to check up on the meters themselves. Just
I just have a quick comment that, we think a lot about citizen science. Well, not only are you letting people gain information or check information relative to other sources, you're actually building their capacity to create these sensors, I think, in a way. So that's a kind of a really fun added part that I see from your project. Are you going to share this with any environmental justice groups or anything?
Yeah, a lot of the work was and still is kind of like does this even work? Is this like feasible or useful? Because there was, and still on a level is, the chance that like we run all of this, we deploy a whole network of sensors and it just isn't enough. Like the sensors just aren't good enough. We have to change them more. Like maybe it cannot be done. Like these are all very possible. And so we at least wanted to get to a point where it was like, we can probably do this. This is the data we can probably get you at this level. This is probably the amount of work that it will take to build this thing, and building it in like a way that could be very, very tailored to the community. So, I mean, it's basically a box you can take out or put in as many sensors as you want. If you put too many sensors in and decide you don't like it, you can plug the hole. And so just making it, giving people as many possible options as we could for right now, and then kind of going from there to ideally let people, I don't know if it would be like AI or just like talking to our team, but basically helping them to see like, okay, what's my problem? What do I want to understand? What can I build? Like what's within like the resources that I have access to? How much money do I have access to? How much space do I have access to? Where am I allowed to deploy these things? And ideally go from that to like full sensor deployment without needing like expert help, which is a very like long, big goal. But I think that it would be the ideal to just like let anyone collect whatever data they would like to collect within whatever like boundaries they are currently in.
Okay. Unless there are any burning questions, I think we're going to respect the clock and close it here. So I just want to say thank you so much to Alexandria, to David, to Ghislaine, also to the faculty mentors that I don't think we ever connected those names. So I'm just going to do that. So Elisa worked with Ghislaine. Robert Adams, who's not here, worked with David, and Larissa worked with Alexandria. So thank you to everybody for presenting the work, and thanks to people who are logged on online, and have a great afternoon.